We do need to be able to read an OSPF config, such as turning the routing protocol on for a process, plugging in the network command to enable the protocol for interfaces, but we also need to apply that to the real world. Let's do that here. We're going to build an OSPF autonomous system from scratch. And so what I'm going to do is this. I'll verify that I don't have any routing protocols on. We'll build our new OSPF network. And I like the network command. I'm going to do it that way for the most part. So I'm going to enable OSPF for all interfaces on R1 in the 10 network for area 1, 2, 3, 4. We're going to run area 1, 2, 3, 4 on areas or routers 1, 2, 3, 4. And router 4 is going to be an ABR. And the backbone area will be the frame relay environment between R4, 5, and 6. Okay, so there we go. That should actually be okay. I'm just going to copy that command. I'm going to go over to R2. And we've got a lot of routers to configure, and I'm going to go through that relatively quickly. We're going to R3. Not going to wait for neighborships. We'll confirm if we think that there's a problem. On R3, I'm going to say network 10, 1. Wildcard masks don't have to match between neighboring routers. They just have to enable the right interfaces. Oh, wait a minute. It just occurred to me. I think I did area 0 on R2. Did you catch me on that? We'll go back and fix it. No problem. That'll add some flavor to our example here. Oh, no. That looks good. I second guessed myself. Okay. So, in any case, we've got R3 properly configured, and I want to make sure that R3 just has interfaces that are in 10.1, and I've excluded my interface going over to the ISP. That is in a different subnet. Okay. Good. R4. Onto that one. Do router OSPF. Now, here I want to be careful. I'm going to do a show CDP neighbors. And I'm going to go over to the interface going to R3, which is gig 20. And then I'm going to say IP OSPF, process 1, area 134. So you can do a combination. I don't really like it this way, and this is probably going to be a problem for me in the future. I'm going to move it to a network statement instead. So I'm going to say no, and I'm going to move it back. I'm going to use the convention that will probably cause fewer issues for me. And in this case, I'm going to pin it down to the exact IP address. So I want to be very careful on R4 not to enable OSPF for a different area. Okay, looks good. We've got our neighborships properly formed. Now R4 at this point should be able to see routes like those routes over on R1 and R2, and it looks good. That looks really good. So let's see what we can see at this point. We'll pause and not worry so much about the rest of the autonomous system. For instance, the connections between R4, 5, and 6, and R7 and the multi-area setup. We see that we've got OSPF routes with an administrative distance of 110, which is the default, at a cost of 3. Probably means we have to go through fast Ethernet links, 3 of them. Now, they may be faster than fast Ethernet, but the default cost for anything 100 megabits per second or faster is a metric of 3. I'll do a show IP protocols, and we can see that we have some relatively generic information revealed to us for show IP protocols. We won't do this in verbose fashion. We won't walk through verbose output just yet, but you can see there's not a lot of details. And part of the reason why is ShowIP protocols was built for distance vector routing protocols, and it's a little less interesting for your link state routing protocols.